All right. So walking around, I was very impressed with what I saw on your sheets. If you're confused, that's totally normal. It takes a while to get used to this stuff, but I'll tell you, when I looked at your diagrams, even if maybe you got one light ray wrong, for the most part, you guys did a very good job. I saw a lot of correct work as I was walking around. And we'll get to questions that you have shortly. Here's the question for the day today. After a storm, you're going to notice some stoplights reflecting off of a wet road. Why do you see that, do you think? Yes? That's exactly right. And that's what you can write down. Light rays bounce off the water. Water acts partially like a mirror. Not completely, but partially. So let's take a quick look at worksheet number 4. What questions would you like to go over? Number 2. Okay, so number 2, we've got the mirror, and it's curved like this. Our object is located here. It extends down, but we can just kind of ignore that like we ignored it when we went through number 1. Focal point's back there somewhere. So we got to figure out where the image is formed, and we got to figure out where that light ray originally coming off that object is going to go. So that light ray that's coming off the object is kind of angled down like that. So in order to figure all this out, we got to find out where the image is located, because this light ray is coming from the tip of this arrow. So wherever that tip of the arrow forms, this light ray, or a reflection of it, has to pass through that location. So, what should I do with the first light ray I throw in here? Parallel, yeah. Parallel light ray is going to come in, hit the mirror, and bounce through the focal point. The next light ray has to somehow have something to do with the focal point, and then it's going to hit the mirror and bounce out parallel, because you've got that relationship between those two things with these curved mirrors. Now, we can't shoot the light ray through the focal point because it wouldn't hit the mirror. So when we can't do that, when the object is in front of the focal point, what we have to do is line up a light ray as though it came from the focal point. That light ray hits the mirror, and that's the one that comes out parallel. So we still have that relationship. Focal point, parallel, parallel, focal point. So now, because these two light rays are never ever going to cross, we have to find a way to make them cross. And because they're moving away from each other out here, what we have to do in that scenario is follow the two reflected light rays back until they actually cross paths. So that's what I'm going to do. There's one reflected light ray, there's the other. They cross right about here, so that means that's where the tip of my arrow is going to form, because that's where these light rays are coming from.
So, how do you know it's not inverted? Yeah, I was confused.
Well, you draw it so it comes back down to this axis. If it was down here, you would draw it up. So it's always got to come back to the middle here, whether it forms on the top or the bottom. So like, yeah, one of the things I saw as I was walking around, if you drew it like this, that's where the arrow tip's going to form. but you always got to draw it so that the object is coming back down to the middle here. And if it forms here, it's going to come back up to the middle.
So wherever it crosses is where you should put the arrow.
Sorry, what's that?
So wherever it crosses is where you should put the arrow.
Yeah.
And then following it back down to the arrow.
You got it. Now the last part of this problem is figuring out where this light ray is going to go. And because this light ray came from the arrow tip, these light rays came from that arrow tip as well. And when we follow these back, they cross in the same place. So when we follow this one back after it bounces, it's going to cross in that place as well. Its light ray, when we follow it backwards, must pass through this same location because it started from the same point as those other light rays. So I just got to line it up. And this is a tough, you're not going to see something like this on a test or a quiz. The stuff that you'll more than likely see on those would be things on page 2. A little bit more basic. So yeah, light ray is going to bounce off, go in that direction. And we know that because when we follow it back, it has to pass through the same point as the other ones. That one's a little bit of a doozy. Further questions on number 2? All right, what else?
6.
Number 6. Yeah. So 6 is like the trick problem on this homework. If number 2 and number 6 were the ones that made you feel uncomfortable, you're in great shape. If you feel pretty good with everything else, you're in very good shape. So now we don't have an arrow, we've got a little string with a circle on top, or whatever that is. And we got to figure out where this image is going to form. So, first light ray is going to come in parallel. It's going to hit the mirror. It is going to go through the focal point. And we're halfway done.
Yeah, but there's no.
What's that?
There's not like focal point.
Yeah. And that's what makes this hard. So the second one, if the object was back here, we would blast the light ray through the focal point and it would come out parallel.
Oh, I agree.
If the object was in front, we would line up a light ray with the focal point, have it hit the mirror, and it would come out parallel.
It's not possible.
Yes, not possible. So this, we can't do much else with. Do you see the little C to the left there? So that would be located right about here. The other thing that we could possibly do is have a light ray as though it had come from this angle, from the C, and have it hit the mirror and go straight back. If we drew that, we would find that those two light rays would be parallel. And what that means is that you're not going to get any image at this location at all. These light rays are never going to cross behind the mirror or in front of it. So what this corresponds to in the real world is, remember the converging mirror where you held it close to your face and you were big and right side up? You held it far away and you were upside down? This represents the position at which your image would be flipping from right side up to upside down. At that location, you would see no image. So it's a very special case. Yes?
I just have a What?
Oh, yeah. So the main thing is that you draw it in the correct spot. So for, like, number 3, your image should be between C and F. So I might just say between C and F. For number 5, it should be a ways to the left of C. So just say it's to the left of C. It's as long as you're drawing it in the right place. I'm not going to mark it wrong if you would write its location wrong. I'm mostly looking at the pictures that you're drawing with the light rays. So however you want to describe its location is fine with me. If you want to say 2 inches to the right of F, that's cool too. Other questions on this worksheet? Yes? Number 4. Okay. So number 4, we've got our object. It is beyond the focal point, maybe somewhere right about there. Focal point's right here. And the first light ray we want to throw in there is going to be what? Parallel. Nice and parallel with the axis. It's the mirror. And it's going to go and bounce through the... Yeah. You can kind of see that. So where do I send the next light ray? Yep, through the focal point. And of course, by the same relationship, it's going to hit the mirror and pop out going parallel. So where those 2 light rays cross is where the image forms. I suppose I should draw the object like it's on the worksheet. So this is where that little ball is going to form, because that's where the light rays came from. And we always want to get in the habit of drawing the image so it goes back to the axis here. So it's going to go like this. When I drew it on my sheet, it ended up being like right below the actual object. So it should be somewhere in that area for you. So it would be inverted. It would be real, because it's a reunion of these real light rays, and it's upside down. And it is about the same size as the original one, maybe a bit bigger or smaller, depending on how you drew it. Other questions on worksheet 4? For the location here, I would say to the left of F. Other questions on worksheet 4? Yes. Number 8. Alrighty, this is the other kind of mirror. It's the other way. So there's our object, there's our focal point. We got to find the image. First light ray is going to come in going parallel, no surprise there. Now if this was a converging mirror, that light ray would bounce back this way through wherever the focal point is. But it's not. This light ray is going to bounce and go up, because this is a diverging mirror. You can think of it like a ping pong ball coming in. It's going to hit this surface and bounce that way. And the angle at which it bounces that way can be found by just lining up this location with the focal point. So that's the first light ray. So that's our parallel focal point. Now I've got to do the focal point parallel. So I'm going to aim a light ray right at that letter F. It hits the mirror, and it bounces off going parallel, of course. And those two light rays are sad now because they're moving away from each other and they will never again see each other. So when that occurs, we got to take these two reflected light rays and we got to follow them back until those cross. So we already kind of did that with this one when we lined it up with the focal point. Now we got to follow this one backwards. They cross right here. So that's where your arrow tip is going to form. And we extend it down to that axis there. And there's our object. Upright or inverted? Upright. Real or virtual? Virtual, yes. Bigger or smaller? Yep, very good. Other questions? Yes? So you know by two things. If these light rays that are actually real light rays, if these would cross, then it's a real image. But if you have to draw them backwards behind the mirror with dotted lines, then it's virtual. The other way to tell is 99% of the time, if your image is upright, then it's going to be virtual. If it's upside down, it's going to be real. Other questions? 9? Okay. So 9's going to be a lot like number 8. But we have a different shape there. It's going to be a circle. And it's on the left side. There's our object, focal point right here, and it's the same procedure as the one we just did. We send in that light ray so it's parallel. It's going to bounce off this mirror up to the left, because that's just what that mirror does. Because it's coming in parallel, it's going to bounce off at the same angle as the focal point is. And then the next light ray we send towards the focal point so that it bounces off and comes out parallel. Those light rays will never ever cross, so we got to follow them back till they cross. That happens here, so that's where our upright, virtual, smaller image appears. All right, so take your worksheets, and actually I should collect them myself. So have those out for me, I'll just grab them. We're going to have a little quiz on this material when you come back on Tuesday. What's going to be on the quiz is pretty much this worksheet directly as it is. So you just want to study this worksheet when I get it back to you tomorrow. And be ready for that quiz on Tuesday. It's not going to be anything tricky. It's not going to be anything new. It's going to be just what's on this worksheet. Yeah. Yeah, that's fine. Oh, sure. Yeah, that's it. just to make sure you're all aware. When you go on Schoology, once again, you do have access to the answer keys to these worksheets. The answer keys are located, if I scroll down, eventually you'll see a folder that says answer keys. And you just open it up, and all the answer keys that are published will be available. So I'll make worksheet 4 available today. The other thing I want to show you is, if I go under light and sound, because that's the unit we're in, light as a particle is the chapter we're in. If you go down to these little yellow boxes, these are walkthroughs. So these are just like what we did, my face is really close. These are just like what we did in class for notes. Just like what we did right now and what we did yesterday. So I just want to make sure that you can see these and get an idea of where they are and how they might be helpful to you based on your own learning style. So this is a certain mirror, and as you scroll through, it just keeps adding different things. I made this a long time ago, but it still works well, so that's good. And everything in red is the new stuff, and on bottom is explaining that new stuff. And so now we've got the object closer to the mirror, and it just explains everything. So it's a way you can go through these examples at your own pace. So make sure you know that's available for you. Now, on to what we're going to do today. We will be taking a few notes, so you want to loosen up your fingers a little bit. You can label your notes today refraction. Refraction. So, because having all the lights off is kind of our thing here. Green laser. And I have here a little tank of water. And we want to kind of figure out what happens as I shine this laser beam into the tank of water. So if I go in from the top, this, you can see that the light is doing a couple of different things. As it goes into the water, probably notice that it does bend a little bit. It's coming down like this, and then it bends downward. So we don't have a straight line when light goes from air into water. It changes direction on us. And the same thing is true if we would come up from underneath. If I shine the laser beam up from underneath here, you can see it goes in the water, and now it's changing direction. You can see it kind of on this white area here. So it's coming up like this, and now it's curving across, more horizontal, once it exits that water. And so the question we really have to answer today is, why is the light changing direction? And how can we figure out what direction it's going to go if we have a laser going from one type of substance to another? And we're going to talk about that shortly. One thing I do want to mention, though, before we do that, when I shine this laser beam in here, do you notice how, let's see, where is it? Got to be very careful not to drop this in the water. See how there's kind of two green lights on the ceiling there? So those are because this light is doing two things after it hits the water. One thing it's doing is bouncing off directly from the water. Part of it is the water acting like a mirror. Most of the light goes into the water and through, but part of it does get reflected. The rest of the light ray is going to go down here, as you can see. It bounces off the bottom and comes back up. So this is something that's kind of interesting, and it's actually the way that if you have a car, it's how your night vision mirrors work. You guys know you have night vision mirrors for your rear view mirror? So here's what the deal is with that. When you have your rear view mirror, if you would look at it from the side and you take the plastic off, it looks kind of like this. This would be like glass. This here would be a reflecting surface, like we talked about the other day. How a mirror is just glass with the reflecting surface behind it. Well, what happens when you use the special night setting on your rear view mirror is this. Normally, here's your eyeball. The light comes in, it bounces off the back of your mirror, and it goes into your eye. That's what most of the light does. But at nighttime, when your eyes are sensitive and you don't want the bright lights of somebody behind you to ruin your vision, what you do is you flip this up a little bit. And usually there's a little knob on the bottom of your mirror. And so what that does is this. Yeah, most of the light hits that reflective part and it bounces into your eye, but just like water partially acts like a mirror, glass partially acts like a mirror too. Part of this light ray is reflected like this. And so when you flip your mirror, it angles it down just a little bit, and now this is the light ray that goes into your eye. This is probably 85% of the light. This is about 15% of the original light ray coming in. So it's not as strong. It allows you to still be able to see things. So that's what's happening with your rear view mirror. It's a little bit of nice real world knowledge there. So we still have some things to explain now though, because this light is changing direction when it goes from air into water. And we got to figure out exactly why that is and how to actually be able to show that when we need to. So that's what we're going to be doing right now. So I'm just going to draw the setup that I have here. The water is underneath, we'll say. And this is air up here. So, the light came in. I'll draw it with red. At a certain angle. When that laser beam came in, did it bend down or did it bend across? Do you remember? It bent down. So for some reason, the light changed direction like that. And it was the exact opposite when it came back up. So the question is, how do we explain this? Best way to explain this is with the toy that I got when I was much younger. This is the Ecto-1 from Ghostbusters. And you can easily use this to explain why light changes direction. Imagine it like this. Light travels different speeds in different mediums, different substances. In the same way that when you're walking through water, it's a lot more difficult than if you're walking through air. light experiences the same thing. Light travels slower in things like water. So think of it like a car. It's moving nice and fast right now in the air. Then all of a sudden, the front right tire is now in the slower substance. So this tire is moving slower. This one is moving faster. That's going to cause the car to turn down. Light rays behave exactly like the Ecto-1 or any other car. So again, you're in a very fast medium. The car is moving nice and quickly. But then it's like the front right wheel is now in the water. It's not moving as fast as the front left wheel. So because this wheel's moving faster, that's going to cause the car to turn down until both wheels are in the slower medium, and then it moves straight again. So you can use that description to describe why light changes direction, not just from a fast to a slow medium, but the other way around as well, as I'll show you. When the light was coming up from underneath, we saw that it bent across. So the same thing is true here. If you begin in a slow medium, maybe it's like a very muddy road or something, and the car's moving now. The front left tire is in the air. Air is a faster medium. Maybe you can think of it just like regular pavement. So because this is moving faster now, and this wheel is moving slower, it's going to cause the car to turn in this direction. And you can use that analogy for any scenario where you're trying to figure out the direction that light is traveling. Questions on that? Okay. There's a few more things I want you to write in your notes before we adjourn for the day. First off, we want to get some vocabulary and things like that taken care of. So you don't have to draw a new picture or anything. You could actually just use the one that you already drew. So this light ray coming in is called the incident ray. The light ray that leaves is called the refracted ray. When light changes direction like this, we call that refraction. So this is the refracted ray. Make sure that you draw a little dotted line that goes straight up and down from the point where the light hits the water. We use that when we look at angles. This would be your angle of incidence. You could also call it your incident angle. And the way that we draw angles when we don't know them in physics is with this little Greek letter. I'll put a little I next to it for incident angle. This right here then would be your refracted angle, or your angle of refraction. Questions on anything so far? Cool. The other thing that we have to take note of is the different substances that the light is traveling through. And so we have two little Greek letters we use for those. It looks like an N. It's not an N, but if you want to call it that, that's fine. We call these an index of refraction. that'll be index of refraction 1, because we're in the first medium, the one where the light begins. And the one here would just be the same thing, just number 2. It's the second index of refraction. The last thing you need to write down is that this little dotted line is called a normal line. So if I say make sure you draw your normal in, that's what I mean. You need that dotted line so that we can make deductions based on these angles. And just kind of in passing as we adjourn then, so light travels slower in different mediums, and it travels faster in different mediums. And there's no real, it's pretty easy to figure out which ones they travel fast in and slow in, because you just think of yourself going through those mediums. The thicker and harder the medium is, the more difficult the time it is for you to travel through it. Same thing with light. See you tomorrow, folks.